till date, even the COVID-19, what we do is with the help of this centrifuge only. So I should really appreciate that the person who has designed this, and how much is useful in the lab, that one. So you can write centrifuge in the Google, no? Centrifuge in biotechnological labs. I think you will get a huge number of different types of instruments. I'm discussing the basic element. So let me call this as its original name. We'll call by its original name, centrifuge. Some different names they're given, but there's a general initial when it was designed, no? So that I'm analyzing here. No, initially the liquid column is attached. So then there's the axis. This is cylinder. Huh? So what it is? Cylinder. You can try this where in the you can try on your own. So take some any cylindrical shampoo bottle or any other thing, fill up water, and with your hands try to spin it. Then you can see this liquid column. So since water is transparent, so add some color to it. Add some color, blue or red color, anything is available, watercolor. Then start spinning it. You can see the surface will take a different shape. Okay, now as it starts rotating, okay, let's get into the concept. So as it starts rotating, so you take this particular small element. What are the forces on that element should be? So that small element, let it be here. So the one force is what? The weight dmg. And it is at a distance r, a force dm omega centrifugal force. So the resultant force will be like this. So like this, if you assume the elements at different positions, so the value of R will change. No? Let me take identical elements. The value of R will be different for different positions. So this dmg, the weight will be, weight of that elemental volume will be constant. But what will happen to the centrifugal force experienced by different elemental particles at different radial distance will be different. And the resultant force, I think initially here, the resultant force will be downward. So as I start moving away, the resultant force will start rotating away from the axis. So here it will be like this. If you choose a particle here, I think this will have maximum centrifugal force and dmg. And the weight will be vertical to the maximum centrifugal. The resultant force will be somewhere more near towards centrifugal force here. So the different particles here, the net force acting on them is different. And also the direction. And what is the one property of free surface? It will always align itself such that the tangential force must be zero, or the net force should be perpendicular to free surface. So there's a one property of free surface here. So the free surface now will take a shape. That's the initial level. Let me show that layer of liquid. Yeah. This is, I'm telling you, there's a boon for the human mankind, this particular topic. I can go to that extent of pricing this equipment. Even till date, they're the only best cheaply available equipment for testing of for most of the elements in the blood or urine. Okay, this is what we have, dm omega square. So the resultant force, how it will be directed? It will be directed df like this. So this particular, if you draw a tangent, only at certain point where you assumed a liquid column. So this tangent will make an angle theta. So this should be the theta. Then what is the basic condition? The net and there's a free surface. The net force along the free surface must be 0. That one. So let's equate that. dmg sine theta. So this should be the theta minus dm omega square r cos theta equals 0. What is the reason? Net tangential force on any point on free surface must be 0. So therefore this, what is the equation? We'll get it here. Tan theta omega square r by g. So what is tan theta? So let me define this as y-axis. And this is r. And let this be the origin. Or you can show it, that axis here, and there's that origin. Okay, tan theta, shall we write dy by dr? Oh, so sorry. It should be. Just that origin I didn't locate properly. Or origin, will take it here. And now look at tan theta, dy by dr. So from the diagram, equating these two, so dy by dr equal to omega square r square by 2g. Look at the free surface, it will take a parabolic shape. No? So what the shape of this free surface will be parabola. Plane diagram will call it a parabolic. So it will be like a paraboloid, no? If the 3D diagram. So once you make omega non-zero, so you make it, you stop rotating it. Then what when the free surface will become horizontal, or it will become like a circular disc. Here plane diagram horizontal. Second diagram, the plane here what happen, the free surface will be parabola, because we are seeing a plane diagram. If you view from the top, here how the free surface circular disc. As you start rotating, it will become a paraboloid. Okay, nothing wrong, since what we are seeing is plane diagram. So therefore I'll select a horizontal and parabolic shape it will be. So this will be the free surface above the axis. What happened? We can get this one. If you take any point on a curve, so it is going to describe it will form a paraboloid here. So like this, the shape of the free surface will be parabolic in nature. Y will be proportional to r. Okay, let's see that now how to calculate the pressure at various points. The pressure at, as let it be rotating this liquid column. Okay, just meanwhile you concentrate, I just fill it up. No. Why it is not coming? I think some of your, from your batch only, they just select, sir, why don't you make it small and fill it up so that you need not to scribble more. I didn't have idea. This one. Let's get into. So pressure at various points in the liquid column. Pressure at various points inside the liquid column. What are the various points on the free surface, at several points on free surface? How the pressure varies at different. So first I'll start with pressure at point 1, 2, 3, 4, 5, and 6. So let's get into the pressure at 1, 2, 3 should be should be equal to P naught. The topmost layer of free surface exposed to atmosphere should have a pressure P naught, irrespective of its shape. Okay, fine. Simple conclusion. Okay, now come for this one. Pressure at 1, 2, 3 is this one. Pressure at 4, it is at a distance. Say like a R, you write it. Let this be depth y. So let's come for the easier things first. We'll find out. So along the axis, this is the axis. Along the axis of P1 plus rho gy minus P5 equals 0, or P naught plus. So how the pressure that varies along the axis? Along the y-axis, it varies with the depth only. Now what about the pressure at 4? Pressure at 4, I should use this formula. Okay, I'll do one thing. P2 plus rho gy minus P4 equals 0. Manometric equation. Okay, this one. Y naught, let me take, this is Y. Two different distances are there, no? Shall we write this? P2 plus rho gy minus P4 equal to 0. What is the pressure at 2? P naught. And at what distance? The point 4 is that radial distance r from the axis. So can I replace Y here using this formula? This is the expression for G will get cancelled. Rho omega square r square by 2. Look at our pressure. It varies radially. So as you move away from the axis, the pressure will increase. That's what the R is says. Okay, now I got pressure at 4. Can we calculate the pressure at 6? They're at same level. So P4 plus rho g y naught minus P6 0. P4 value, we know it. Okay, the rho plus rho g y naught equal to P6. I think you have a very good set of discussion here. How the pressure varies on the axis only with the depth. What about here? Yeah, of course, if you want, you can say with the depth or also with the radial distance according to this equation. What about here? It varies with the depth as well as also the radial distance. Are you getting? No, we have y naught and also r. Able to make it out. So I think you have to break up this particular liquid column into parts. Like this region is one. Okay, this region. Of course, you can say that it varies with only depth, but you see what is y? Y is equal to again omega square r square by 2g. So it's a practice that to show that as you move here, the pressure increases radially here. What about here? This point is at a depth and also it's at some radial distance. So the pressure varies here at both with the depth and radial. So shall we conclude? On the axis varies with the depth. In this region, what happened? It varies with radial distance, whereas here varies with the depth as well as the radial distance. Now, what is use of this? I told no something like this one. I'll fill up like something like a my blood sample to be tested for some virus or bacteria. Then my blood sample contains many other things, no lipids, fats, everything. Then again, white blood cells, red blood cells, all the things, no. Then I'm going to add a solution for it. and that solution, what will happen? The chemical will react with lipids in one way, with vitamins in one way, then with virus present in one way, with bacteria present in one way. I will make it to rotate. And look at this, one more thing, like a pseudo force dm omega square r. So based on this dm, what happens? The different particles will experience because the different elements or the different elements there will have different mass, like a lipids, vitamins, proteins. That molecular mass will be different of that one. So because of that, what happens? The different particles, they experience different radial force and the weight, and they will settle at different positions in the liquid column. Those which are heavier, they will settle here. Those which are lighter, they will float here. And that what happens? The flotation depends on like how much of their density. At different point, they'll float it here. And some will get submerged and some will be here. Then what happens? I'm going to collect from the different regions for 100 ml of the liquid. I'll collect from here. Then I'll start counting how many particles are there for 100 ml. With that, what happened? We brought a methodology. Okay, if this particular count is more than this, test is positive. If the count is less than this, the test is negative. Like that, it was designed. A lot of science is behind it. So when you get a time now, do visit. Don't visit now during COVID time. After vaccination comes now, do visit biotechnological labs. Just ordinary labs you visit, no, you do have centrifuge equipment, so much of physics involved here, especially all related to fluid statics, fluid dynamics. Nothing new. What all you want to view things, no, you can go for it. Okay, fine. So the heavier particles will settle here. The lighter particle will float. And those particles whose density equal to that of the liquid, they'll get submerged and they'll be here. And now one more thing. How much the liquid? I think there are some books they have started asking this one only. How much it has raised at the edge, that much it will fall here. I think definitely we have to go to the mathematics of the parabola to show that. So I'll just put it. The rise of liquid at the edges should be equal to the fall of liquid at the axis. Provided what happened, the axis should be symmetric. And definitely I think it's a symmetric. I wrote R and R, you can see that one. So how much it will rise at the edge, that much what happened, it will fall here. So the rise of liquid at the edge should be equal to fall of the liquid at the axis here. I think this from mass we have to show it, no other way. I'm just concluding this one directly as an information. So rise of liquid at the edge should be equal to fall of liquid at the axis. And now, what are the, can it here also, can it spill out? Just we'll have some small discussion, then I'll come to the numericals. Here also, will it spill out in these situations? Let me take a situation like this. No. I have to give a condition, no? Yeah. So there's a height of the cylinder. Let it be h, and let it be filled to a height 2h by 3. Then I'll rotate about a symmetric axis. There's everywhere, this is a liquid. Huh? I don't have time, so I'm just putting that one. Now it starts rotating. As I keep on, for any angular velocity, will it be parabolic, or only for specific angular velocity will be parabolic? I'm asking some very generalized things. Only for specific angular velocity or for any angular velocity? For any angular velocity, the shape will be parabola. No. Will it touch the brim? This is called like a brim. This is called like a brim. And this is called like a base. Now, will it simultaneously touch both the brim and base? First, the rise of liquid at the edge should be equal to fall of liquid at the edge. For the liquid to rise to the till edge, so how much it should fall? So h by 3 it should rise, no? Here h by 3 should rise to touch the brim. To touch the base, how much it should fall? 2h by 3. So will it touch the brim and base simultaneously? The answer is no. So if I show the free surface, I'll do one thing. No other alternative. Will just the theoretical ideas I'm trying to conclude in the form of numerical only. The previous one, what I discussed, I just making some numerical with that. No, this is the question what I'm asking myself. When the liquid was touching the brim, no. So when the liquid was touching the brim, what about the liquid at the base? At what height it will be? So what can we can put it? H by 3. H by 3. And this is H by 3, no? So will it touch both the brim and base simultaneously? The answer is no. When the liquid touches the base, what will be the liquid? What will be the liquid? Will it any spillover will occur? Yes, there'll be some spillover. I'll show everything in one diagram. Oh, oh. Come for this. So in the next situation, when the liquid touches the base, not symmetric. Now, what should be the state of the liquid? Any spillover will occur? Or you'll be tested with a very best simple idea-based questions of these things rather than focusing on maths, no? So definitely the teacher will be interested to analyze your basics, geometry basics. Oh, hash to show. Yeah. No. Any spillover. So this will be some new angular velocity, no? Omega 2, this omega 1 you call it. Or for same angular velocity, new angular velocity it should be. Now the liquid, what will happen? Any spillover. My question is, will there be any spillover, or you look at the amount of liquid present? Is it same in third and second, first, second? First, second will be same. Huh? What is the volume of liquid? V naught. Now also the same volume. V naught, V1. V1 equal to V naught. about to spill. What about here? The volume of liquid definitely is V2. V2 will be less than V1 or less than V0. Some liquid will spill out here. Getting some idea? Like this, you continuously increase angular velocity, the liquid starts spilling out. So this is what, this is a spilled out liquid. So this is the free surface. Some liquid got spilled out. So now, sir, I'll increase. Can it happen like this? Can it happen? Okay, if it is filled up to height h by 2, then it will touch the brim and base both simultaneously. That's what I mean to say here now. No, sir, can it happen where the liquid will be like this? Yes, it can happen. Plus, get ready for questions of these kind also. Now, definitely this omega will be greater than